Problem 58, length of last word. So basically we are given a sentence which is a bunch of non-space characters, yeah, and interleaved with a bunch of space characters. And here is the last word, and we have to count and return the number of non-space characters in the last word, right? Last word, 1, 2, 3, 4, 5, 6. So we have to return the 6. I'll probably do 2 solutions for this problem. One will be perhaps a JavaScript developer solution, and then I'll try a more of a competitive programmer solution. So S is our string, right? So we got to return something that we're going to do with S. So first of all, trim right. Yeah. What this trim right will do is we need to get rid of all of these spaces here. So these spaces will be removed by trim right, and that's an important step for whatever I'm going to do next, right? So trim right. Then let's split, and we're going to split by what this will do is, well, S is a special character, which means a space. It is not just a traditional, so white space, any type of white space. This could match tab, space, anything that can be considered white space. And obviously plus means one or more, one or more. It has to be at least one and any number above that. So that's a regular expression, right? So I'm going to split this by a regular expression, which will do basically, this will create an array, potentially an empty space in the beginning because we have these spaces. So if you split it by spaces like this, you'll get an empty space at the first element of the array. Then hello, the second element of the array. So empty space, right? Then hello, mad, with commas. Yeah. So anything that is non-space, these will be elements of the array, right? So 0th element, first, second, third, fourth, fifth, sixth. And technically here we would have had an empty element as well. But since we got rid of these spaces here, this element will not exist. This will be the last element. And I think that makes sense, right? Because if you split by spaces, even if there is nothing here, well, you have to split by the spaces. So this nothing or an empty string has to be technically the last element, right? So we split it like this by the empty space. Now let's get the last element, right? So if you get the last element, then it's basically this string world with the exclamation mark, exactly the bit, the part of the string that we need. So potentially, you know what, I'm going to do dot length, and the question mark is there. We won't need the question mark. The question mark is still there because just in case S does not really contain any non-space characters, then this will return undefined, and this will give you an error. So this question mark here protects you from that error, and it will return undefined. So this whole thing returns undefined if this is undefined. So, but I don't want undefined, so instead I'm going to return 0, right? So if this basically protects you from returning undefined, right? And that is a solution which we can try. I'm going to call this a JavaScript developer solution, okay? It may not be perfect, but it passed the pre-tests. Let's see how it does on the actual suite of tests. Okay, running. And we passed, right? So runtime beats 100% of solutions and memory beats 89% of, well, 90% of solutions. That is an unexpected result, to be honest. That's very good, okay, for JavaScript. Now, let's try a more competitive programmer type of solution, right? So, for example, this code, you can't easily convert it to C++, for example. So let's write a solution where we control memory and everything slightly better, right? So here we would be using loops and things like that. So basically just explicitly doing loops. So more imperative solution, right? So basically we will have a pointer, let's call it I. And the first part of the program would be to get I pointing to this last, or maybe, yeah, we need to point to this last character here. All right. So this bit, this exclamation mark, or whatever the last character in the word is. So basically we need to start from the end and travel the string until we encounter something that is non-space, right? Let's do that. Let's do that part. So get rid of this solution. Let's create a variable I and set it to s length -1. That's a good starting position, right? Because if there are no trailing white space characters, then we are just looking at the basically last character, right? But in case there are white space characters, then we're going to run a small loop. The first thing we're going to always check that I must be at least 0. That's important, right? We do not want to run over the end of the beginning of the string. This will not be needed, obviously. I mean, looking at the description of the problem, there will be at least one word, right? If there going to be at least one word, we're never going to run over the beginning of the word, beginning of the string. So we're going to keep this while SE is an empty space. And while this is true, we're going to keep reducing I. So when we exit this loop, the only way to exit this loop is one of these conditions has to get false. So which means either we have exhausted the entire string, so I will be less than 0, so -1, which will only happen if there are if every character in S is empty space, or no characters maybe. Or we are looking at SI, which is a non-empty space. And that's what's actually going to happen according to the constraints, right? SI must be equal to empty space when we exit this loop. This is just for consistency, that if we get a weird input for this problem, right? Now we're going to initiate count. Now we're going to start counting, right? So count will start from 0. And notice there is certain kind of elegance. There's going to be some elegance. So we create this I variable here, do the loop, create count, and now we're going to do another loop very similar. So now here, we also have to keep checking that, I is at least 0. But this time, this actually is important because technically we could have this word could be the only word. So no white space, nothing preceding it, the only word in the sentence. So this might actually, this is basically a required thing to do. This time we're going to keep running this loop until, instead of checking while we are looking at the white space, we should be running this exactly the opposite. While we're not looking at the white space, we should do two things. So two things, right? We have to keep reducing I and increasing count, right? Now this comma here ensures that these two are a single command. So both of these will be evaluated in a loop. Now, obviously, I could do it with curly braces and stuff, but just for elegance, I mean, just for some sort of symmetry, for these two loops to look the same, I'm going to do it like this. And now we're going to return count. And that's it. I think that's our second solution. Let's try it on the pretests. And we passed pretests, and now keeping fingers crossed. Let's see how that performs on the actual suite of tests. Oh, that performed even better, right? Beats 100% of the solutions and slightly more in terms of memory. I mean, it's hard to say who did this with less memory. But I mean, that's it. That's our solution.